Okay, I want to show that I have done the bridges, the jump wires in a different configuration, but it's actually the same thing. It just I just turned the whole commutator from the image that I have been showing on the forum, but it's the same thing. This is the 1 2 3 4 4 3 2 1, and here it's happening the same way. I'm sorry, 5 6 7 8 and 8 7 6 5, and then it starts again at 1 2 3 4 4 3 2 1. So the sequence is the same. It's just I just rotated the way that I had it before, but it's doing the same thing. Now, related to this setup I have here, on what I was talking about on the forum, it's these are the 8 coils, 2 sequence groups. N1 will be right here, and you can see it there. N1, 2, 3, 4, and then S5, 6, 7, 8. And like I mentioned, they are kind of loose because the secondary it came out shorter. So I had to redo the steel core and the secondary, and this is not tight, as I wanted to show also the movement in this the magnetic flow that it takes place here, since they are not tight. Now, related to self-inducing each others, I have solved, kind of momentarily solved that issue by adding the 2 running caps that you've seen before. They're 40 microfarads, and they are from a running generator exciter system. I use 2 because 1 is for each sequence group. You cannot use 1 for the 2 groups because you'll be short-circuiting the 2 circuits, and they got different timings. So when 1 is on running the sequence, the other one is getting fed. So they work alternated. Okay, so I'm going to first input 14.0 volts, and this camera doesn't capture that well as the iPad does, but it came out blank. It's 14.0. It's too bright, the screen. I have thought of putting a tint film on it. Anyways, it's 14.0 volts. I'm going to take off the camera that way I can show you. It's 14.0. Now, one thing that I wanted to share with you is that you should add, like I did here, it's a little switch, and it's in order to open and close the positive, and it's attached to the positive to the brush. So when I see something wrong with the system, or I want just simply to stop it, I just click here, and this is an on and off switch that is regulated to the type of amperage that I'm going to be running here, which is around 10 amps. That's the maximum that power supply can supply. So I'm going to run first. I don't have the light bulb connected. That meter right here, which went off right now, I'm going to have it showing the output, but I'm going to be running it, and I got connected channel 1 to the output, so you see the wave that I'm getting. So, and the bulb is connected. You can see a little light there. And as I accelerate, now there is one thing that I want to bring it here. It's 14 volts feeding the both magnetic fields. When it's not enough power feeding the sequential coils, the exciting system, what happens is when you accelerate the speed of the frequency, it doesn't climb. You see it's 21.7. Now it started to decline and the bulb is lit. Of course, if I take the bulb off, it's 24 volts. But I want it with the bulb on. So when you see that you start accelerating and it starts decreasing in there, I'm gonna cut off the power. So it means that there is not enough power on the magnetic field to let you accelerate beyond a certain point. There is a spot that the field will not keep increasing the output. You need the field with certain power so the magnetic field can induce enough on the output. Okay, that's one thing. I wanted to run it real low now and show you a quick demonstration here. I'm gonna take the bulb off, and I want you to see how the field exchange is in here by using this neo magnet. You see that it's turning because of the magnetic pulses, even though we are in the outside area of the sequential coils. So that's how strong the field goes out in space. And as I increase speed, well, there's a point that it loses synchronicity with the magnet. And as soon as I turn off the system, magnet stops. It gives you an idea of the volume of the field pulsations. Now I'm going to increase it to 28 volts and run it real slow. This is an interesting point. Okay, now it's at 28 on the power source, and I want you to see at low speed what the fluctuation of the coils is. Remember, they are north against north. Blue and south are two identical poles. So once that I start the sequential movement, they repel each other in a sequence and they move in a certain flow. And I want you to watch that. So, and at 14 volts, it's not enough power to give to this. I'm gonna keep it slow. I'm gonna turn on the small switch I told you, and you can see how they are shaking. Now, once that you get higher speed, you can see that I'm gonna get the light bulb on. So you can see fluctuations in there. Now the next video I'm going to make is I'm going to have this one sequential coil group. I'm going to disconnect it from the, I'm going to disconnect the red, and I'm going to just keep the blue, and I'm going to measure the total induced power by the blue on the red, and I'm going to transfer it to DC so you guys could see the difference, what the output they self-induce. All right, thank you.